All right, so this is the remaining problem that we did not go over in class today for the quiz on matrices, on subtracting, adding, and multiplying matrices. All right, so this is the first problem that we didn't do, which was 2c minus a. These were the matrices C and A. So the first thing to recognize is that these two matrices are identical in terms of dimensions, and that's what it takes to be able to subtract them. So the first thing I did was multiply C by 2. That's everything in matrix C by 2. So everything here is just double that. All right, and then I wrote matrix A over again, even though I guess you don't really have to do that. But so basically when you subtract or when you add, you work from one number to its corresponding number. So I'm saying negative 0.2 minus negative 1. So when you say negative 0.2 minus negative 1, what you're really saying, because you have two minuses back to back here, is plus 1. So negative 22 plus 1 is negative 21. 18 minus 2 is 16. Negative 14 minus 3 more is negative 17. 10 minus negative 4, so again, minus and negative really means plus. So we're actually saying 10 plus 4 is 14. Negative 6 minus 5 more is negative 11. And 2 minus a negative 6, that's like 2 plus 6, so our answer is 8. And this will be your final answer, to 2c minus a. So multiplying is maybe a little bit more complicated because you have to know the dimensions of each thing to determine whether or not you can multiply. So this one is 2 rows and 3 columns. This one is 3 rows and 2 columns. So we're saying, can you multiply E times C? And the answer to that is yes, because these numbers in the center match up. If they match up, your answer is yes. The numbers on the outside tell you the dimensions of the answer. So our answer is actually going to be a 2 by 2 matrix. So it'll be a very small one. Which is okay, small is good. So what you're going to do is take the rows of the first matrix and multiply it by the columns of the second one. So essentially what I'm going to be doing here is taking this row of numbers times this column of numbers. So I'm actually going to undo that just to take that out of there, but so you know which ones I'm talking about. So it's going to be for row 1, column 1 then. It'll be 0 times negative 11. So 0. Then I move to the next number in the row, the next number in the column. So again, row 1, column 1. 2 times negative 7 is negative 14. And 4 times negative 3 is negative 12. That's a grand total of negative 26, which goes here in our answer. Okay, so that was row 1, column 1. Now I'm going to stick with row 1, but I'm going to go to column 2 instead. So it's row 1, column 2. 0 times 9 is still 0. 2 times 5 is 10. And 4 times 1 is 4. Grand total of 14. Still in row 1 right there. Okay, but I've taken row 1 times both columns. Now I'm going to move to row 2 and start the process over again with column 1. So 6 times negative 11, 8 times negative 7, and 10 times negative 3. I guess that one's meant to test your addition skills a little bit. Let's see. I'm thinking 110, 140, and 12 more, negative 152. That's here. And now I'm going to take row 2 times column 2. So this row times the second column, 6 times 9 is 54, 8 times 5 is 40, and 10 times 1 is 10. Grand total of 104. Right in here, 104. So now, basically you can say, well look, I've taken each row times both columns. That means I'm done. So whenever you have one of these sets of matrices, the thing you want to say is, did I take this row times both columns? Did I take this row times the column? And if there was another row, did I take it times the number of columns? The idea is that ultimately every row has to get multiplied by every column. So in this case, it happened to be that it was only 4 things that we had to do. In class, we did the one that was longer, that was the 3 by 3 times the 3 by 3. Depends on what the size is and how big the answer is, but the principle is the same no matter what. Always a row times a column, a row times a column. Okay, that's really it for the matrices. There's not much else to do.